In this video, we're going to work some problems focused on the general properties of aqueous solutions. But a bunch of these problems are going to focus on specifically the electrolytic properties, because the reactions we're going to study in this chapter, precipitation, acid, base, and redox, are based on ions being dissolved in solution, which is directly related to electrolytic properties. Okay, first problem. Define solute, solvent, and solution by describing the process of dissolving a solid in a liquid. So instead of using NaCl, let's use something different. Let's say we have KNO3. And let's also go ahead and use sugar as an example. Okay, so we could be dissolving potentially in any liquid, but let's use water. Water is going to be present, and we're going to have a homogeneous mixture or a solution, a mixture of substances. Water is going to be present in the larger amount. So the water is going to be the solvent. And then in these two cases, this KNO3 would be the solvent and the sugar will be the solvent. Once this is dissolved and this is dissolved in the water, then you have a solution. This gets dissolved, it breaks up into K plus aqueous and NO3 minus aqueous. This just becomes C12H22O11 aqueous. These get hydrated. They get completely surrounded by water molecules. They break up, and they're all and these ions are surrounded by molecules, by water molecules. That's what being dissolved means. Here, these don't break up into ions, but they don't stay together in sugar clumps. All of the individual molecules get hydrated. They get surrounded by water molecules. They dissolve and become and so it becomes aqueous. So a solution, you've got a solute dissolved in the solvent. So we're talking about a liquid here. You've got the solid solute dissolved in the liquid. So it's a solution. And dissolving means that the solute doesn't stay together in clumps. All of the individual molecules or ions, depending on the situation, get surrounded by water molecules. So that's what dissolved means. Okay, what is the difference between a non-electrolyte and an electrolyte, between a weak electrolyte and a strong electrolyte? All right, so the term electrolyte means that if you have for electrolyte, we're talking about aqueous solutions. We're talking about something dissolved in water, in liquid water, okay? The term electrolyte means that if something is an electrolyte, that solute, once it's dissolved in water, the resulting solution conducts electricity. And so that's the difference between non-electrolyte and electrolyte. If it's a non-electrolyte, no matter how much of the solute you dissolve in water, the resulting solution will not conduct electricity. An electrolyte means that as long as you dissolve at least some kind of significant amount, you can't just put like a tiny speck of the electrolyte into the water. You just put some decent amount, then it will conduct electricity, the solution. So an electrolyte, it must be soluble to some extent in water. It has to be, because it needs to dissolve, and not just dissolve, but also break up into ions, right? Sugar dissolves, but doesn't break up into ions. So sugar is a non-electrolyte because you need those ions dissolved in water for the solution to conduct electricity. Now, a weak electrolyte, the difference between a weak electrolyte and a strong electrolyte, we've got both of these are electrolytes, right? Weak electrolyte, strong electrolyte, both are electrolytes. Both, when dissolved in water, conduct electricity. A strong electrolyte, like hydrogen chloride gas, every single mole, every single molecule completely, every single molecule dissolves into H plus and Cl minus. Every single molecule. That's what a strong electrolyte means. A weak electrolyte, not every single molecule dissolves. Only some do. And also, and furthermore, the reaction is reversible. So well, okay, so we've got CH3COOH aqueous. So these all, even all of the CH3COOH gets dissolved, but not all of it is dissolving into ions necessarily. Okay, so you see the difference? So we might have every mole gets dissolved, right? We've got this CH3COOH is fully aqueous. It's dissolved, but it's not completely dissolving into or dissociating into ions like this. Dissociating is the correct term. Dissociating, and it's reversible. It's constantly, it gets to equilibrium, but it's constantly going back and forth in both directions, recombining and disassociating. Here, there's no reverse reaction. It's all goes to the ion state and stays there. So this is a strong electrolyte. This is a weak electrolyte. Describe hydration. What properties of water enable its molecules to interact with ions in solution? Okay, hydration is when an atom or a molecule or an ion or some sort of ionic compound gets bonded to one or more water molecules. So it undergoes hydration. It becomes a hydrate. When something is dissolved in water, whether or not it dissolves into ions or not, it becomes hydrated. If it's going to dissolve in water, it's going to become hydrated. So with, like an ionic compound, NaCl solid, this completely goes to, it's a strong electrolyte, Na plus. These ions get hydrated. They're completely surrounded by water molecules. That's what dissolve means for in the case for water. For really anything, but that's what hydration means. When something is dissolving in water, it's completely surrounded by water molecules. Water molecules are very polar. They're not. So this is H2O. They're not ionic, but they have a good amount of skewed positive charge on the hydrogen and negative charge on the oxygen. So a lot of oxygen surround Na plus, and a lot of hydrogen surround Cl minus. For sugar, so this goes to completion as well. All of the sugar dissolves and becomes aqueous, but there's no ions, but it still gets dissolved, and this sugar gets hydrated. It's surrounded by water molecules, and the idea is there's a bunch of OH groups in this molecule, and those OH groups are very polar, so the skewed negative charge on those O's interacts with the positive charge on the H2O molecule, and then the skewed positive charge on the H's in those OH groups interacts with the negative charge on the water molecule, and that's how it becomes hydrated. What is the difference between the following symbols in chemical equations? This arrow, so we talked about that. This single arrow means that the reaction it's one direction. It doesn't occur in reverse. It's not reversible. This means reversible. This means non-reversible. The reaction takes place, and all of the reactants stay as they stay, like they stay as they are. But this is a reversible reaction. You can have the reaction going in both directions. It goes in the forward direction, but also there's molecules that are kind of like, you can think of it recombining into the reactants. And chemical equilibrium is a state when you have a reversible reaction where the rate of the forward reaction is equal to the rate of the reverse reaction. So it's like nothing's happening when the reactions are still constantly taking place, but it's you don't have the amount of reactants changing or the amount of products changing because it's in equilibrium. Water is an extremely weak electrolyte and therefore cannot conduct electricity. Why are we often cautioned not to operate electrical appliances when our hands are wet? Yeah, okay, so this is because tap water is not necessarily pure water. There's dissolved salts, which make it conductive. It's not necessarily pure. That's why. Sodium sulfate is a strong electrolyte. What species are present in Na2SO4 aqueous? Okay, so Na2SO4 solid, dissolve it or introduce it to water, and yeah, so it separates into its ions. So you just look at how does this ionic bond form? This is what? Sodium plus 1, right? And then SO4 2 minus, right? And then you would bring the 2 down here and the plus over. So it breaks up into this. This is an ionic compound. It just breaks up into its ions, and the ions dissolve in the water. So you get Na plus aqueous plus SO4 2 minus aqueous. The aqueous solutions of 3 compounds are shown in the diagram. Identify each compound as a non-electrolyte, a weak electrolyte, and a strong electrolyte. Okay, so the strong electrolyte, the definition of a strong electrolyte is it dissociates completely. Every single mole, every single molecule dissociates into ions. So here, we still have intact molecules here. They're not dissociated. So it seems that they're suggesting that these are like separated into ions completely. So this is, we'll say, is the strong electrolyte. Okay, now a weak electrolyte, well, let's go to non-electrolyte. A non-electrolyte doesn't conduct electricity when dissolved in water. And so you can think about that as the molecules, maybe they dissolve, but they don't separate into ions. So I guess they're suggesting here that, I don't know if these are dissolved, maybe they aren't dissolved, but they're not, they're trying to suggest that none of these are separated into ions. And this is a little confusing because you can still have a non-electrolyte that dissolves a little bit into ions, but it's nowhere close to the number of ions you need to conduct electricity. But I think what they're going for is that none or a negligible amount separate into ions. So this is the non-electrolyte, and then so this would be the weak electrolyte because only one of these, only a portion are separating into ions. Which of the following diagrams best represents the hydration of NaCl when dissolved in water? The Cl- ion is larger in size than Na+ ion. Okay, so if we look, let's look here first. So this is the Cl- ion, this is the minus. This is the Cl-, this is the Na+. You've got a Na+ oriented with the oxygen here. Okay, that's correct. And then it looks like the hydrogens are oriented with the Cl-. Okay, and it looks like that's pretty consistent. All right, so this is probably the right one. Let's just see. Here we've got the hydrogens, the plus, oriented with the Na+. No. Right, we've got oxygens oriented with the Cl-. So the oxygen's negative. No. Here you've got oxygens. Well, wait a minute. Okay, hold up. We can come back. There's another thing I missed here. There's no such thing like, okay, here we've got NaCl. You don't, when an ionic compound dissolves in water, you don't have, this one is suggesting that we have NaCl aqueous. No. You don't have an ionic compound aqueous. It doesn't dissolve this way. The NaCl, the NaCl doesn't break down into individual NaCl components that then get hydrated. So I should have noticed that in the beginning. This is wrong. An ionic compound is going to break down into the individual ions, and then, as you can see, the negative lines up with the sodium, The oxygen lines up with the sodium, and the hydrogens line up with the chlorides. So this is the best representation. These are both incorrect. Identify each of the following substances as a strong electrolyte, weak electrolyte, or non-electrolyte. Okay, so you can either Google, so make sure you've got a good quality reference if you Google this, or check your chemistry textbook. Let's get a chart for electrolytes. Okay, you don't have to memorize this. You just make sure you have a good reference for it. All right, H2O. Okay, H2O is classified as a weak electrolyte. It gives a note here. Pure water is an extremely weak electrolyte. So it's not a non-electrolyte, it's a weak electrolyte. Okay, potassium chloride. Well, we don't see potassium chloride anywhere, but we know that potassium chloride is an ionic compound. All ionic compounds are strong electrolytes. Okay, HNO3. We see HNO3 here, strong electrolyte. CH3COOH. That's a weak electrolyte. Okay, C12H22O11. That's sugar. And so sucrose, or table sugar, non-electrolyte. And we talk about why that is. It's very soluble, but it doesn't dissociate into ions. It just dissolves, the neutral molecules dissolve. So this is a non-electrolyte. The passage of electricity through an electrolyte solution is caused by the movement of what? A, B, C, or D? Electrons only, cations only, anions only, both cations and anions. Yeah, so what happens is, for an electrolyte, you have the dissolved ions, and the positive ions move towards the negative electrode, and the negative ions move toward the positive electrode. So it's the movement of both cations and anions in the water. Predict and explain which of the following systems are electrically conducting. Okay? Solid NaCl, molten NaCl, and an aqueous solution of NaCl. Okay, so the way you can think about this is, can the ions move? Because with NaCl, you've got ions everywhere. Even solid NaCl, it's a bunch of ions everywhere. Na plus Cl minus, that's what it is. It's ions. It's made up of ions. It's neutral, but it's still individual ions. Can those ions move? If they can, then it's going to be able to conduct electricity. So in solid NaCl, the ions can't move. If you put electrodes, maybe the ions kind of want to move, but they can't. In molten NaCl, the ions can move. The ions can migrate towards electrodes. So this would be able to conduct electricity. In an aqueous solution, this is a strong electrolyte. It definitely can. It's the same idea. The ions can move. Once the electrode is there, the ions can migrate. Okay, you are given a water-soluble compound X. Describe how you would determine whether it is an electrolyte or a non-electrolyte. If it is an electrolyte, how would you determine whether it is strong or weak? Okay, so determining whether it's an electrolyte or non-electrolyte is easy. Because this just means it either conducts or doesn't conduct electricity when dissolved in water. So put a lot of it. Take a lot of the compound and make sure you put maybe even saturate it in solution. Put a lot of it, right? Because if you just put it, you can put a strong electrolyte in solution if you just put a tiny sliver and see if like a light bulb lights up, right? So what you do is you have two wires or something connected to a battery, and then you dip those two ends, they're called electrodes, into water, and they're separated though. So there's a potential between them, and if the water can conduct electricity, the light bulb will light up, right? So you have them connected to a battery, and in between that circuit is a light bulb, right? You have a battery going through, and then a wire from one terminal goes through the light bulb, and then the other terminal meets up it goes into the water. And if you can conduct electricity, the light bulb lights up. If you've got a lot of the solute of the compound dissolved, because like even if you had just a tiny sliver amount of a strong electrolyte dissolved in water, well, the light bulb won't light up because there's not enough ions. But if you put a lot, then either if it's a non-electrolyte, the light bulb won't light up at all, even though there's a lot dissolved. And we know it's going to dissolve because it's water soluble. But if it's an electrolyte, it's going to if it conducts electricity at all, you'll see the light bulb light up. So you'll be able to determine if it's an electrolyte or a non-electrolyte. Now, whether or not it's strong or weak is a little bit more involved. What you could do is you could take a known strong electrolyte. And so when it's a strong electrolyte, that means that the definition is it fully dissociates. So take equivalent molar amounts of a known strong electrolyte and your compound. And then both of them should have the same brightness of light bulb because all of the moles dissociate. You're going to get equivalent amounts of ions. If the unknown compound doesn't light up as much, that means that it's not fully dissociating. And so you have a weak electrolyte. All right, explain why a solution of hydrogen chloride in benzene does not conduct electricity, but in water it does. Okay, so the idea here is that, so we have a solution of hydrogen chloride in benzene. So hydrogen chloride dissolves to some extent in benzene. To some extent, meaning, does it dissolve as full HCl molecules, or does it dissolve by breaking up into ions? Well, benzene is non-polar. Like how water is polar, benzene is non-polar. So it's the polar aspect of water that allows it to break up ionic compounds or kind of these polar compounds like HCl. So in benzene, it's going to be surrounded by benzene molecules in this HCl form. So it doesn't conduct electricity. There's no ions, even though it dissolves in benzene.